recording will start shortly. It shouldn't take us long. Okay, right, so there is the recording. So remember, distance, any type of distance is measured in meters. Velocity or speed is meters per second. Now remember, we write it like that. Do you remember? I don't know if I ever explained why. Okay, because normally people write it like that. Okay, but now the problem with that is we don't do that in science. Okay, so that means meters per second. It means meters divided by second. But remember, in maths, when you have something like this and you take it up over the divide sign, you get that. The exponent changes to a negative. Okay, so that is why we write it like that. And in science, we always write it like that. You know what I must do next time? I must put my laptop this side so that I can see you and look at them at the same time. Okay, time always in seconds. So don't feel like you have to, if you get given something in hours, you have to convert it to seconds. Right, and then acceleration is always meters per second squared, because that is your change in velocity over a time. So it's meters per second per second. All right, then, I'm sure you've seen this kind of thing before, where it goes, I know there's another rhyme as well, but this one is King Henry died a miserable death called measles. So basically what it does, it puts them into hecto, deca, and you're getting the kilometers, what you need to do. Now, the ones we don't normally use hecto, we don't use deca, the rest we use. Okay, so those two we don't normally use. And you can see there's a tenth between each one. So if you're going from kilometers, for example, and you want to go to centimeters, can you see how you times it by 10, 10, 10, 10, 10 to get to centimeters? So it's, what's that, 10, then 100, 1,000, 10,000, a million. That's right. 10,000. Yes. Okay, so that is how you do this. And if you want to go from, say, centimeters, you divide by 10, divide by 10, divide by 10, divide by 10, divide by 10. So it's about looking at this rhyme, and it will help you. You know what? You will eventually start picking this up so quick that you won't even need anything like this. Okay, so I always say to people, well, if you need to go, if you have kilometers, remember kilo, what you can also remember is that kilo equals times 10 to the 3 because it's big. Okay, so if you're going from, if you're saying, and think about it, 1,000 meters, and we want to go to kilometers, right? What you need to do, oh, sorry, this is the wrong way around, I'm doing this. 1 kilometer, sorry, let's do that, not that one. Then we know that's 1,000 meters. Okay, so we know that, but if I replace the K with times 10 to the 3 meters, you see, look how I've changed it into the SI unit. So as long as it says meters, and instead of putting the K, I put times 10 to the 3, which we know is 1,000. 10 to the power 3 is 1,000. 10 times 10 times 10. Okay, so, and you can leave it at that. Because it's science, we love scientific notation. Okay, so you don't have to convert it any further than that. So that's how easy a kilometer to a meter conversion would be, is literally replace the K with the times 10 to the 3. So centi, you can replace the C with a times 10 to the minus 2. Think about it, centi, it's like century, it's hundredths, so it's 2 zeros. So that's where the 2 comes from. And because it's so much smaller, remember, kilometer is bigger than a meter, but a centimeter is smaller than a meter. So you'd have to have the negative. And then milli would be times 10 to the minus 3. Okay, because it's 1,000th of a meter. So if you want to convert a millimeter to a meter, all you do is you replace the M in millimeter with times 10 to the minus 3, and you convert it to meters. Okay. All right, this is the the difficult one, but I'm going to show you how to do it. You don't need to know how to do it, but I'm going to show you why it works this way. Okay. And then you can just learn off by heart what you need to do to convert this. But again, because I don't like you working things off by heart, I prefer you to understand something. So I want to teach you how to do it. All right, so let's think about that. This is kilometers per hour, which is what we use in everyday language, okay? So we've got kilometers per hour. We want to take to meters per second. Now, it's not as easy as you think it is because we've got two things we're converting. We're converting a distance and we're converting a time. So what we do is we go, all right, kilometers, and what we want to get to is meters per second. So if I was to do that, we know, remember I want to go to meters per second. That's what we're aiming at. Okay, so how many meters in a kilometer? There's 1,000 meters. So I'm going to convert that to 1,000 meters. So 1 kilometer is 1,000 meters. Okay, let's just make it as 1. 1 hour. Now we need to go to seconds. So what do we need to do? Just getting my calculator here to show you. I'm sure I passed it. No. Okay, because you can actually work out for me. I didn't take my calculator. How did it go? Okay. All right. So first we convert to minutes. How many minutes in an hour? 60. How many seconds in a minute? 60. So you times by 60 times by 60 twice because you're going from hours to minutes, then minutes to seconds. So that should be 3,600 seconds. Happy? Okay, and if we times that by 1,000. So that's what we did. So we went 1 kilometer times by 1,000 gives us 1,000 meters. 1 hour times by 3,600 gives us 3,600 seconds. So look what we've done. We've basically, what we need to do is you have to times by 1,000 over 3,600. But let's just consider this. So kilometer per second, okay, 2 meters per second. What do we need to do to now just get straight from there to there? So if we times, if we say 1,000 divided by 3,600, we're going to get another number, but I don't want to do that with you. What I'm going to do is I'm going to flip these two around. So I'll get the bigger one over the smaller one. Then we get a 3,6. Okay? And then what must we do though if I swap those two around? I have to change that to a divide. Okay, so you can times by 1 over 36 if we simplify it, or you can divide by 3,6 because it would be 36. Sorry, that's 10. 36 over 10. Okay, so to go from there to there, all you need to do is divide by 3,6. Okay, so that's all you need to remember is your 3,6. Just what you need to do, you need to remember if it's divided times. Okay, so we know that if we times it, it would have to be the other way around. So the 1,000 divided by 3,600. But if we change that around so that we get the 3,6, we divide. Okay, so just if you remember this, you'll be fine. So if I give you, I traveled 120 kilometers per hour on the highway. So let's have a look at the limit on the highway. So 120, somebody divided by 3,6. 33,33 meters per second. Okay, so 120 kilometers per hour is the same as saying 33.33 meters per second. Now think about that. You have to cover 33.33 meters every second. That's quite a lot. It's going really fast. That's going 120 k's an hour. Okay, so it's really, really fast, and then we know that that is meters per second. If I give you meters per second and I ask you to convert it back to kilometers per hour, you times by 3.6. Okay, but I just showed you here, why do we get 3.6? Okay, questions? No?
No, ma'am.
Okay, so while you're on here, I want you to do this activity. Well, think tank. 2, I think it really is just conversions. So please, you must be confident with conversions. I don't want you guys to tell me like end of the year or next year you have no idea how to convert. Okay, this is something that you should be able to do quite well. Right, so number 1, 5, 8, and 9, we can do it now. We can mark it at the end of the period. Yeah, we've got still more than half an hour left. Okay, while you're doing that, please stay online. While you're doing that, I'm going to load the declaration forms. Girls, are there anybody there that can invigilate for you? Because actually I need an invigilator. Oh, I found my calculator. Okay, I'm sending you both, and I'm going to be sending it to your parents as well, those declaration forms. I swear I'm going to fall off the chair. Sorry, girls, I'm just trying to connect you. You see how weird her chair is? This whole thing is like broken. Oh. Okay, that's working. It's okay. It's just weird. Okay, let me just take a look at them. Okay, now I'm showing you faces. I'm just going to leave, if my microphone or the noise here is causing a problem, just let me know and I'll turn it on mute. Otherwise, it will be nice to just interact with each other. Okay, let me put the declaration forms on. This is getting warmer, guys. Yeah, I'm sure, because I was freezing in my little house. Okay. Ooh. Just mechanics. I've given you direction, and I've given you so bearings. You must know how to get bearings. You must know how to resolve the purple line, the resultant, into the two components. You must be able to also get your resultant out of more than one resultant. Yes, yeah, you must know your truth. What I've done is I've scaffolded the questions. So in other words, I've guided you through them. So it's not just a work out the resultant course. It's work out the components. Now work out the resultant. Now work out the complete resultant. Now work out the direction. Okay, so I've done it step by step to help you. Okay, and what I'll do is I'll carry mistakes. So if you make a mistake in the first one, I'll use your answer there to see if you've done it correctly in the next one. Okay. Oh, let me do that. My throat's actually sore. It's so weird. I swear, I've been running around like a crazy person. It's just a converting exercise. If anybody has any questions for tomorrow's test, you're welcome to ask now as well. So one of the grade 8s was speaking to me and she's talking to me. I have no idea who she is. You can't see, and I don't know them well enough. Because I only saw them for the first term. So she's talking to me about the things like, oh, I don't know who you are. She says, I see you today. And I'm like, you don't look like a grade 11 or a 10 or a 12, but that's all I have today. Oh my gosh. So, okay, let's refresh this as well. Well, when do I need to send your name? Let's wait and see. Daniela, yours is still not through. You have to send your name. I don't know what that means. I have absolutely.
Ma'am,
Yes?
for our test tomorrow, what will we have to know from page 5?
Frames of reference.
So not the like bottom half, the SI units.
No. Well, you
Oh.
always have to know that. But
Yeah.
frames of reference.
Okay. And ma'am, for bearings, like if you don't give a degree, do you get such a, like if you have to say like north of west, can you also say something like east of south?
You can, but then it's not a bearing. That's the only problem. A bearing is really only an angle.
So if you could 30 degrees east of north,
It is a correct direction, but it's not a bearing. Yeah, a bearing has to, it's the angle from 0 degrees to wherever it's pointing. Yeah.
So it'll always be like something of north.
No, you don't say anything. You just say a bearing of, and then a degree sign, a little circle. You don't need to say anything about north, south, east, or west. You just have a bearing. It's just an angle. What you should realize is that anything before anything before west is under 90 degrees. Anything between east and north is greater than 90 but smaller than 180. Anything between 180, north and west, let's say east, but I said west. I said the right thing. Okay. Anything between north and west would be between 180 and 270, and anything between west and north would then be greater than 270 but less than 360. You would never put 360, you always just say 0 again. Right, it's essential name. I don't know what that means. I'm sorry if it means anything. She might come and just measure your temperature.
now you have to know those polygon methods.
No.
Comes with me, I was like, oh, I don't know what that means.
Yeah, no, don't. You know what it is? It's if you walk and 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 you walk, and there's a whole lot of little distances, and then somebody just runs straight from there to you. So that's the resultant, and then this whole thing made this weird shaped polygon and not just a simple triangle. But we never work those things out. What we used to do it like to scale drawings. So each centimeter was equal to like a meter. And then you had to draw them to scale, and you had to take a protractor and measure the exact bearings. And thank goodness we don't have to do that anymore. I'm already tired. Can you imagine me by the end of the day? Yeah. But you know what? I had to come back. It was time. I felt so out of it. Girls, and I won't include your parents in here. How's it going, guys? Sorry?
Just positive, you
Oh, dear. It starts off at the top again. Oh, wait, I must stop recording.